This is the fifth question based on strain energy. So in this question it says that a 200 kg mass is dropped on a collar. So dropped from a collar, that means the type is impact load case. Okay, so here it says that a 200 kg mass is dropped onto a collar at lower end of a particular bar 3 meter long and 28 mm in diameter. So here in the case of impact load, what we know is this one end is fixed and this is the rod, where at the end of this rod the collar is attached, and here in some height there will be some weight, that is here what it says that at the lower end of a particular bar is 3 meter long. So here it's given that the total length of the rod is 3 meter and 28 mm in diameter. So the diameter of this rod, its diameter is 28 mm, and here the calculate the height of the drop. So height of the drop, see here this mass will drop onto a collar. So here it says that we have to calculate this height, that is h is equal to question mark. So now if the maximum stress is not exceeded 120 Newton per mm square, so here stress is also given, that is 120 Newton per mm square. So what is the corresponding elongation? So we need to find the delta L value also. Delta L, it's nothing but the change in length here, and this E value is also given. This is E value. Okay, take E is equal to 2 into 10 to the power 5 Newton per mm square. So these values are given in this question, and what we need to find is the value for h is equal to question mark. H is with this height from the load to this collar, and delta L value. So here here I'll write all the given datas. So now type is what? Impact loading, and mass is given, that is 200 kg. So we need to find the weight of this. So W is equal to M into G. M is 200 and G is 9.81, is equal to, we'll get around 196.92 Newton. And here what is given? Diameter is also given, D is equal to 28 mm, and if this diameter is given, we can find the area, cross-sectional area of the bar. A is equal to pi by 4 into D square is equal to, we have this D value is known to us, that is 28. So just we need to put the value of D in place of D, we need to put the value 28. So we'll get the value around 615.75 mm square. Now what we need to find here is this H value and delta L value. So for the impact load, since our since this is a impact load case, so in case of the impact load, stress can be determined from this formula, that is P by A plus root under P by A the whole square plus 2E P H upon A H. So this is the formula. So now here see this stress value is also given here. Stress is given. What was that? Yeah, this stress is given, that is stress is equal to 120 Newton per mm square. So just we need to put this stress value here. 120 is equal to P is what? 1962 upon A is 615.75 plus root under 1962 upon 615.75 the whole square plus 2 into what was the value of E is, I'll write it down, into 2 into 10 to the power 5 into P value is 1962 into H is like we need to get the value for H divided by AH area is 615.75 into what was that? AL. This is the AL, it's not H, okay? So L is the total length. What was the length? This total length was 3 meter long. So 3 meter long. So L is equal to 3 meter. So in mm it will be 3000 mm, right? So now here we need to write is 3000. So after evaluation, what we'll get here, the H value is equal to 32 meter. Now this is the height of the load to the collar distance. Now in the question, what we need to find is, we need to find the elongation as well. So we know that elongation is the change in length, that is delta L is equal to sigma L upon E. So what was the value of sigma here? Is 120 is given in the question, na? 120 sigma, yes, sigma is given in the question, that is 120 into what is L? L is 3000 and what is E? 200 into 10 to the power 5. So we'll be getting around 1.8 mm. So this is the value for delta E, that is 1.8. So in this question, what it says that we need to find the height of the drop and the elongation. So here this is the height of the drop and this is the elongation. Thank you.